Okay, so this is just going to be a quick review on how to solve for missing sides and angles in right triangles. So this just goes back to SOHCAHTOA, where you use sine, cosine, tangent ratios in order to solve for sides and angles. So these first two are just solving for a side. All you do for these, we have the 35-degree angle. X, what we're solving for, is opposite. 10 is our hypotenuse, so therefore we are going to use sine. So we just set up that sine of 35 degrees equals opposite over hypotenuse. Solve for x. So in this case, to solve for x, multiply both sides by 10. And we get x equals 10 sine 35. Type that in your calculator and you have your answer. And keep in mind, this is 35 degrees, so that means your calculator should be in degree mode. And in this case, if you plug in your calculator, you get 5.7 as your answer. Now in the second case, I included it because the placement of the variable switches. So look at our 50-degree angle. 20 is our adjacent. X is our hypotenuse. So in this case, we're going to use cosine. 50 degrees equals 20 over x. So now to solve for something in the denominator, first you need to get it out of the denominator. So in this case, you essentially multiply both sides by x. And this tells us x times cosine of 50 is equal to 20. So now to solve for x, divide by cosine 50. Remember, cosine of 50 is just some number. Type in your calculator, 20 divided by cosine of 50. And for this problem, you would get x equals 31.1. So now when you're solving for an angle, this is where inverse trig comes to play. So we want to solve for this angle x. We have the opposite and the adjacent. So therefore we use tangent. So we just set up. We know tangent of x is going to equal 2 over 7. So to solve for x, we need to take the inverse. We know x is going to equal inverse tangent of 2/7. And plug that in your calculator. And we get that x is 15.9 degrees. So if you're solving for sides, you use regular trig. You're solving for angles, you use inverse trig.